We've identified a number of systems that cover relatively small aspects of the natural and the human world. But because air is a common resource across planet Earth, air pollution crosses many systems and many boundaries. And human activity contributes to both this outdoor and indoor air quality. To understand air pollution and its effects, we need to look at air pollutants just in general, like where do they come from and what happens to them after they're released into the atmosphere. So next we're going to identify some major air pollutants around the globe, and we'll examine the specific air pollution situations that occur with photochemical smog and acid, acid rain, and we'll also review a variety of other air pollution control measures and examine ozone depletion, and we're going to conclude with indoor air quality. Since one of the major repositories for air pollutants is the atmosphere, which envelops the entire globe, we need to think about air pollution as a system, as a global system. In fact, evidence appears to link air pollution across long distances. In recent years, air pollution in Asia has been responsible for acid rainfall out on the west coast of the United States. So air pollution is a system that has many inputs, which are the source of pollution. And it has many outputs as well, which are components of the atmosphere and the biosphere. It is difficult to conceptualize this system because the inputs do not originate from one location. So air pollution inputs can come from automobiles and on the ground and airplanes in the sky or even vegetation, really. Similarly, air pollution can also be removed or altered by vegetation and soil and components of the atmosphere like clouds and particles and even gases. So the starting point for understanding the global air pollution system, we need to identify the major pollutants and determine where they come from. In formulating this U.S. Clean Air Act of 1970, amendments to legislation used information from environmental scientists and other resources to make the most important air pollutants monitored, and we needed to control them. So the original act identified 6 major air pollutants that significantly threaten human well-being, ecosystems, and they are sulfur dioxides, nitrogen oxides, carbon oxides, particulate matters, and we're going to go into a couple more. So sulfur dioxide, SO2, is a corrosive gas that comes primarily from the combustion of fuels like coal and oil. It's a respiratory irritant, and it can adversely affect plant tissues as well, not just mammals and things that breathe. So because all plants and animals contain sulfur in small to large amounts, the fossil fuels derived from the remains of other organisms, they basically contain sulfur. And when those fossil fuels are combusted, the sulfur combines with oxygen to form sulfur dioxide. Sulfur dioxide is also released in large quantities during a volcanic eruption, and it can be released in smaller quantities like through forest fires. Nitrogen oxides are generally what we call NOx, N-O-X, with an X that indicates that there are many, 1 or 2 different oxygen atoms per nitrogen atom. Is how that works, like NO or NO2. NO is a colorless, odorless gas, and nitrogen dioxide, NO2, is a very pungent and reddish, brownish gas. Uh, and so we will use the term nitrogen oxide, also affectionately called NOx by environmental scientists, to go on further with our discussion here.
Mom, look what I made from a jelly.
Oh, okay. Alrighty, so when we use the term nitrogen oxides, we're going to be referring to either NO or NO2. The atmosphere is about 78% nitrogen gas, and that is N2. And all combustion in the atmosphere leads to the formation of some sort of nitrogen oxide. Motor vehicles and stationary fossil fuel combustions are the primary source of nitrogen oxides. But there are natural sources too, like forest fires and even lightning storms and microbial action that occurs in soils. So atmospheric nitrogen oxides play a role in the formation of ozone and other components of smog too. So we're going to take a closer look at this a little bit later. So carbon oxides, or specifically carbon monoxide, CO, is a colorless, odorless gas that is formed during the incomplete combustion of most matter. and therefore it is a common emission in vehicle exhaust and most other combustion processes too. Carbon monoxide can be a significant component of air pollution in urban areas. It can also be dangerous to indoor air as well, because exhaust systems from like natural gas combustion, um, like your stove or a grill, and even heaters, if they malfunction, they can produce carbon monoxide. Perhaps you've heard stories. But carbon monoxide is a particular problem in the developing world because that's where people like to cook with manure and charcoal or kerosene, and they're inside these poorly ventilated structures. Carbon dioxide is a colorless, odorless gas, but it's formed during the complete combustion of most matter. And that includes fossil fuels and biomass, just in general. CO2 is absorbed by plants during photosynthesis and it is released during respiration. In general, the complete combustion of matter that produces carbon dioxide is more desirable than the incomplete combustion that produces carbon monoxide, if you will. But burning fossil fuels has contributed to the additional carbon dioxide in the atmosphere that's led to it becoming a major pollutant. So recently, a concentration of 400 parts per million in the atmosphere um, is what it appears to be, and it's like steadily increasing each year. So this is a topic that we're going to have to discuss here in detail further, and especially in our climate change section. Particulate matters, also known as PM, or particulate particles, those are like solid or liquid particles that are suspended in air. And their sources come from different places. But particulate matter comes from the combustion of wood, animal manure, and other biofuels like coal and oil and gasoline. And it's most common known as a class of pollutants that are released from combustion of fossil fuels like coal and air. So diesel-powered vehicles give off more particulate matter in the form of black smoke than do like gasoline-powered vehicles. So particulate matter can also come from road dust, like rock crushing operations. It can also come from volcanoes and forest fires and dust storms, which are important natural sources of particulate matter. But particulate matter can range in the size from zero point zero 0.01 micrometer to about 100 micrometers. And for comparison, a human hair has a diameter that's roughly 50 micrometers. So particulate matter can be really large or really small, but unfiltered out of the air, it can get into your nose and your throat and cause problems. So the size is really not regulated, nor does the EPA care about what size it is or classify it. They're more concerned about it just being an air pollutant in general. And this is because particulate matter also it scatters and absorbs sunlight. So if the atmospheric concentration of particulate matter is high enough, it would definitely be an immediate following a large forest fire or volcano eruption. Incoming solar radiation in that region would be enough to reduce and affect photosynthesis. So that's the problem. And this actually happened in 1816, a year after a large volcanic eruption in Java. It released more than 150 metric tons of particulates that slowly spread around the globe. And that year is commonly referred to as the year without a summer. It basically reduced our atmosphere to a haze, and it occurred by scattering light, and it decreased photosynthesis all over the planet. Anything that reduces visibility is called a haze. Oxides are reactive compounds that move electrons from other substances. So photochemical oxidants are a class of air pollutants formed as a result of sunlight, hence the word photo, acting on a chemical compound like nitrogen oxide or sulfur dioxide. There are many photochemical oxidants, and they are generally harmful to plant tissue, human respiratory tissue, and construction materials. So environmental scientists frequently focus on ozone, which is O3. It's a secondary pollutant made up of three oxygen atoms. that are bound together, and it's harmful to both plants and animals, and it impairs respiratory function across the board. In the presence of sulfur and nitrogen oxides, photochemical oxidants can enhance the formation of certain particulate matters, which contribute to scattering of light. And the resulting of this mixture is called smog, a mixture of oxidants and particulate matter. So the word is derived from combining smoke and fog. Smog is particularly responsible for this hazy view that reduces sunlight, which we observe in many cities. And smog can be divided into two categories. They are photochemical smog, which is dominated by oxidants like ozone and sometimes called like the Los Angeles type smog or the brown smog. And then there are sulfurous smog. And sulfurous smog is dominated by sulfur dioxide and sulfate compounds. And we sometimes call those London type smogs or gray smog or an industrial smog. I bet you're surprised to find out that there's lead and other materials in the air. Lead, Pb, its element symbol, is a trace metal that occurs naturally in rocks and soils. And it's present in small concentrations in like fuels, like oil and coal as well. But lead compounds are added to gasoline for many years to improve vehicle performance. And during that time, lead compounds released into the air traveled with those prevailing winds that we talked about in the beginning, and they were deposited on the ground via rain and snow. And so they have become pervasive around the globe, and even in the polar regions, far from where the combustion sources occurred. Lead was phased out of gasoline as an additive in the United States somewhere between 1975 and 1996. And since then, its concentration in the air has dropped considerably. A campaign to phase out lead using gasoline globally is still underway. But there's another source of lead that has become a problem, and that is lead-based paint in lots of buildings. So when the paint peels off, the resulting dust or chips can be toxic to the central nervous system, and it can affect like learning and even intelligence, particularly in young children who are, attracted to the sweet taste of paint chips. Another possible mention here that's not mentioned in your slide is mercury. That's another trace metal. It's also found in coal and oil, and like lead, it is extremely toxic to the central nervous system of humans and all organisms. So the EPA regulates mercury through this hazardous air pollutant program, and as a result, the release of mercury into the air is primarily due to the combustion fuel process, like coal. And so the concentrations of mercury in both air and water have increased dramatically in the most recent years. Mercury concentration in some fish have also increased, and people who eat a lot of fish increase their own mercury concentrations as they eat. There's an example of this interconnectedness between everything, of air pollution, just air quality in general, water, aquatic health, and even human health that environmental scientists are most interested in. And over like the past 20 years, mercury emission in the United States has come from anywhere from like waste incinerators, to coal-fired electricity power plants. And it still remains to be the largest uncontrolled source of mercury emissions seems to also be power plants. And so the emission standards for coal plants are likely to be a huge focus here in upcoming years. All right, moving on to VOX, volatile organic compounds. Organic compounds that evaporate at typical atmospheric temperatures are called volatile organic compounds, or VOX. Many VOX are hydrocarbons that contain carbon and hydrogen bonds, like gasoline or lighter fuel or dry cleaning fluid, oil-based plants, perfumes, a lot of this stuff. So compounds that give off a strong aroma are often VOX, since the chemicals are easily released into the air. These VOX play an important role in the formation of photochemical oxidants like ozone. And VOX are not necessarily hazardous, but many of them are given off by certain trees, like conifer trees, and so they don't particularly harm anything. But VOX are not currently considered to be a critical air pollutant yet. But that's because they lead to the formation of photochemical oxidants that they're now starting to become more of a concern by pollution scientists as we learn more about them.